Same material, same dimensions, even the same 3D model. So why can one quote be 5 times higher than another? It may all come down to one extra zero on the drawing. The tolerance goes from plus or minus 0.05 millimeters to plus or minus 0.005 millimeters.
It looks like a tiny change, but it cuts the tolerance window by 90%, and that can drive your manufacturing costs up fast.
So where's that extra money going? First, machining costs. A standard CNC machine can usually hold plus or minus 0.05 millimeters without much trouble. But at plus or minus 0.005 millimeters, you may need higher precision equipment, extra finishing passes, and tighter control over machining parameters. Complex features may even require precision grinding or wire EDM. That means more machine time and higher processing costs. Next up, inspection. At plus or minus 0.05 millimeters, a micrometer may be enough, but at plus or minus 0.005 millimeters, you may need a high accuracy CMM, controlled conditions, and more inspection time. All of that adds equipment, labor, and time to the final cost. Then comes the third cost, rework and scrap, at plus or minus 0.005 millimeters. Even minor tool wear, or the release of internal material stress, can reduce the yield. Manufacturers have to factor that risk into your final quote. First mold can achieve tolerances as tight as plus or minus 0.005 millimeters when needed. But before we spin a spindle, we verify whether that tight tolerance is actually necessary. Our rule is simple. Use tight dimensional tolerances or appropriate GD&T for critical features such as bearing fits and sealing surfaces, and reasonable general tolerances for non-critical features. Here's a common mistake. More decimal places don't automatically mean tighter tolerances. Writing 10.00 instead of 10.0 may look more precise, but the actual requirement comes from the tolerance callout. And dimensions don't work alone. Tolerance stack-up and incorrect datums can cause assembly problems, even when every individual dimension passes inspection. That's why our DFM review checks the entire drawing from critical tolerances and datum schemes to the full tolerance stack before production begins. If you're developing a high-precision part, send your drawings and 3D models to First Mold. Our engineering team can help balance functional tolerances with practical manufacturing costs.